Welcome everybody to NAPHN Live. My name is Ken Levinson. I'm the Executive Director of NAPHN, the North American Passive House Network, and it's my great pleasure to introduce today's talk by Greg Fischer Architects, on Millhaus case study, finding harmony between health, comfort, and performance. I've had the pleasure of getting to know Greg a little bit since becoming Executive Director last fall, and really excited to see this talk. I just want to say a couple of words about the North American Passive House Network. We are a national nonprofit charity organization, really dedicated to educating professionals, tradespeople, developers, all aspects of the building industry in passive house design and construction. We're affiliated with the Passive House Institute in Darmstadt, Germany, and the International Passive House Association. And really the power of what we do is bringing together the global knowledge networks from around the world and finding those connections and local applications and adaptations. So we encourage everybody to become a member. You see we have various regional chapters, the Rocky Mountains being one of the founding chapters, from New Mexico all the way up through Idaho. We have members about, and if you're in the Rocky Mountains, we encourage you to join it. I'd like to have a brief shout out to our sponsors who are critical in allowing us to do what we do. And a couple of quick announcements. We have ongoing courses. So tomorrow is the one-day introduction to passive house standards. A great introduction, but it's quite in-depth and great case studies and really a lot of meat on it for somebody who's not sure they want to go for the CPHD, but want to get a bit more than an hour might allow. The Certified Tradesperson course is starting up again on Thursday. It's on demand with a kickoff webinar on Thursday evening, and we are doing that in collaboration with EMU systems, and very excited about that. So it's not too late to get into that class if you know somebody that needs the training. And then the Certified Passive House Designer course, we have it now on demand where you can join and start the modules at any time. And the exams are done over a series of times over the course of the year. So it gives a lot of flexibility to folks who have a hard time taking full days and weeks out of their work schedule. And then finally, just to note that we have the conference coming up. It's June 10th and 11th. It's a day-and-a-half conference, national, international in scope, with projects from across the US and from around the world for that matter. It's really exciting. It's a hybrid conference. We are doing it in person in New York. And thank goodness Governor Cuomo is to announce the lifting of virtually all restrictions as of tomorrow in New York State. And but it's there also online. And it's an exciting expo, a lot of networking things. We've put a lot of effort into making it much greater level of connectivity than your typical online experience. So I am going to leave it there and hand it over to Andrew Mitchler of Passive House Rocky Mountains for a quick intro and handoff to Greg. Andrew, are you frozen? I think he might be frozen. My audio is good though, right?
Yep.
I'm good. All right, so I'm gonna, if Andrew unfreezes, I'll hand it back, but otherwise I'll soldier on here. So the Passive House Rocky Mountains mission is to fight climate change by driving the transformation of the built environment towards healthier, more equitable, high-performing, zero-carbon outcomes through the promotion of the International Passive House Standard. And the next meeting is not April 21st. Do we have the next meeting? I think it's tomorrow.
Tomorrow, actually, May 19th.
Yeah, I did not catch that. The meeting is tomorrow. So if you go on the NAPHN event calendar, You can register for that if you are in the Rocky Mountains. We encourage everybody to become a member. You back, Andrew? Not yet. I'm going to introduce Greg then. Greg Fischer is is the founder and principal of Greg D. Fischer Architect, established in Fort Collins, Colorado in 1993. Greg is a licensed architect in the state of Colorado, holds a master's degree in architecture from Montana State University, and is a Passive House certified professional. Greg has received several awards for his architectural work and his efforts in sustainability, including several awards from the city of Fort Collins and the Passive House Institute. And I had on my screen, up until I thought Andrew was going to do this intro, your webpage, Greg, where you had your list of values, which I thought was very inspiring, and I was going to read them, but I encourage everybody to go to Greg's website and look at the About Us and his list of values there. I think they're really solid, and it was a very nice reminder to me of what matters. And so with that, without further ado, Greg, take it away.
Well, thanks, Ken and Gael for sponsoring, for hosting, and to Andrew. Thanks for also the mention on the webpage. Yeah, that's good to hear. Have to qualify that. I have not touched my website in about 7 years. I've been grossly negligent. I need to get some new projects on there badly. So maybe this will be the impetus for that. So let me share my screen here. Are you all seeing that? Okay.
Yep.
So
It's
we
not
call
a
the project.
There we go.
Okay. We call the project Millhaus, and the two parts of that. The mill is taken from the fact that the project is located on what used to be a cherry mill. Hasn't been for many years, but used to be a cherry mill. The original cherry mill structure is still with us, and it's to the right of this photo. It's a house now doesn't look much like a house because it's been added onto so many times, but it is indeed a house. And then the second part of the word house, obviously spelled the German spelling H-A-U-S, and so that's sort of the passive house piece to the name and the metaphor. And basically, one of the things I've admired for several years is sort of what's known in architectural circles as regional modernism. And it's basically a form of modernism that is modernistic, but it still responds to a building's locale, as opposed to maybe earlier editions of modernism, which sort of, somewhat ignored context and didn't think necessarily much about energy efficiency and performance and so forth, but made beautiful buildings that just sort of kind of dropped onto sites. But some of the best examples, there's many examples all over the planet, but some of the examples that come to mind, I think of, are Pacific Northwest and what Millhaus has been doing, and James Cutler architects. I also think of the work like Plato does in the Texas and many other areas, and I think of Glenn Murcutt in Australia, and so just to name a few. And so I've been in search of my form or the Colorado form, Colorado Plains in particular, Colorado Plains and Foothills version of what regional modernism is, what expresses our area. And when I do that, I try to look to buildings that stand the test of time. And the ones that I think generally do this are more the ones of our agricultural heritage, things like a cherry mill, although the cherry mill that happens to be next door wouldn't be an architectural prize, but just sort of that spirit of a mill is what's influenced me here. And when I think of mills, I generally think of kind of pure gable forms that often have rich materials and rich natural materials, and then they'll often also have some industrial materials mixed in, such as steel, etc. And then usually they kind of get added on to later with varying parts and pieces. So in the case of my project, that metaphor sort of came to life in these elevations. It's easier to see than the actual architectural photos. But you can see kind of three gables. In my case, they're asymmetrical gables as opposed to symmetrical gables, and that was to introduce some clear story windows up above lower flat roofs. And the flat roofs are the elements that kind of hyphenate the gables in between the gables and have more of the industrial and steel elements. And sort of the idea is to kind of create an intentional compound-like form of architectural expression. And then to further enrich those masses, those more modern masses, we're again using natural materials. In this case, bark siding, echoing the cottonwood trees nearby, and then we have accents of white fiber cement panels at key areas like entries and these key corners that you see, and then kind of zooming into that a little bit, you can get a better feel for the bark. That is actually a cradle-to-cradle material. It's harvested from a tulip poplar tree, kind of native to the North Carolina area, and was provided by a company called Barkhouse. Then the white trim elements sort of around the windows are a product called Rich Light, which is a FSC certified paper-based product. And then the white panels are, of course, cement fiber with some recycled content in them. Here's the back side of the house. Forgive me on the pile of furniture there. We're still in construction. We gotta get that tidied up and get better photos eventually here. Speaking of the goals of the project, our goals were to downsize from our previous house, push high performance and sustainability. And I wanted to demonstrate that, I'm trying to get that out of the way there, demonstrate that Passive House can be executed beautifully, not just technically. And then of course I wanted to also pursue my own design exploration. This was our previous house. I'm not going to talk too much about that unless there's time later, but it did have an influence on the current house, but I'm going to leave that for now. The site plan, north is up in this image, and you can see that the house is kind of elongated to the east to west. We are 10 degrees off of true south. There's a little bit more I could talk about on the orientation that I'll also leave till later if time permits, but wanted to give you a feel for kind of generally how we're oriented and how those masses spread out, and then the landscape elements will further kind of anchor the building to the site and elongate those accesses. Here are the main level floor plan. You can see those three gable masses are highlighted in gray. And they kind of consist of the bottom rectangle is the primary living spaces, kitchen, dining, living. The middle rectangle is the bedrooms and offices. And then the upper rectangle is the garage and shop. The program for the house was intentionally modest. It's 2 bedrooms, 2 bathrooms, and 2 offices, along with the typical living areas, a laundry room and a mechanical room. And we're trying to, make the footprint or make the size of the house as small as we reasonably could handle. And we had some kind of back and forth on that between my wife and myself, but I was aiming to try to get to about 2,500 square feet. We ended up more like 3,000 square feet, but about 600 of that square footage of area is our 2 offices. We both work from home and have for many years, even pre-COVID. So I guess we got to about 2,500 if you take the offices away. And then the thought was that for somebody else down the road, when this house is occupied by the next users, that those 2 offices could become 2 bedrooms or a bedroom and a rec room or something of that like. And then another bathroom has also been planned for in that area. Looking at the inside, the metaphor of the mill attempts to continue, again, with natural materials. So you can see some reclaimed brick used there, the wood ceiling, barred wood, There is white oak on the base of the cabinets there that has been wire brushed. And then of course there's the steel, natural steel elements, the color tie is up above. And then off to the right in the image there, and central to the plan, we have a pantry that is mostly enclosed in steel columns and beams and perforated metal panels. And the idea of that was that it was sort of the mill metaphor again, and that's sort of the tool crib of the house, like you'd have a tool crib in an old mill. This is the same space looking in the opposite direction, so you can see more brick, where we have a two-sided fireplace, that pantry on the left, and then there's a coffee bar back behind on the left, and then the place to the right there. A couple other images of the kitchen area showing again those industrial steel elements in the pantry. This is the living room, so this was the area tucked around behind the fireplace. That two-sided fireplace, and again continuation of those natural materials, and then the steel, kind of the old gridded windows separating the coffee bar from the living room area. Always loved those windows in old mills. They are not, as you all know, energy efficient because they're basically a thermal bridge at every steel frame, and so being able to express it on the inside was the goal, and not being able to do it on the outside in a passive house, of course. A couple other interior images. The image on the right is actually of my studio. I happen to be sitting to the lower left of that image in an area that's got mostly unfinished cabinets. That's why the photo doesn't go down that direction. There's the coffee bar on the left. And then talking more about the other half of the name, the house, the HAUs, the passive house. My passive house story really sort of indirectly began somewhere around the turn of the millennium when I had kind of an awakening period where several things in my life changed, thinking in my life. But one of the preeminent ones was kind of my thinking about sustainability, and I wanted to, live and practice much more sustainably. And so initially, that I found my greatest learning and experiences came through the USGBC, U.S. Green Building Council, and through LEED, and I immersed myself into several efforts in that area in projects go beyond LEED, working towards regenerative practices and projects, and was involved with several lesser known entities and systems in that regard. But somewhere about 10 years ago, I would say, I started becoming exposed to passive house, first through a German friend of mine that had relocated here, and he was telling me about passive house, and I thought he was talking about passive solar, like so many people still think. But anyway, got exposed there and began to learn more and more through various local efforts. And then ultimately, about 3 years ago, took a course from EMU Building Systems and became a certified passive house tradesperson. And so that's when things really started getting more serious for me. And in addition to doing a couple of projects that were sort of near passive house projects, but not certified. And the CPHT training through EMU, really sort of solidified things. And then that also exposed me to their program, their pilot program, where they're trying to work with builders to do passive house projects and try to make passive house more obtainable and user-friendly for builders. And I like that idea, not only for myself as a builder, but also trying to help other builders as well. And so I signed up to be part of that pilot program. And that really gave the project the structure and the know-how and systems and experience to be able to go after passive house certification. Passive house, was something that we intended to do from the very start. So it was integral to the design process. It wasn't something we tried to add on later. And it was integral to the construction processes as well. And so initially I started out working kind of the way I typically do with green projects, trying to organize the masses on an elongated east-west axis, try to move the primary spaces to the southern side, try to move the spacers that are better for buffering, like garages and bedrooms, to the north side, etc. And then also plugged in the building envelope systems that EMU was working with their pilot program. And so we got kind of to a place about like you see in these very massing studies here, where we had a floor plan, we had massing, et cetera, and we had these assemblies, and then we had EMU ran a preliminary passive house review using Design PH and other tools, and created this report that you're seeing the cover page and a couple of images here from. But the report basically indicated that we were pretty much on track with the basic form of the house and the amount of windows and where the windows were put and where the shading devices were put, et cetera. We're pretty much on track to achieve certification, but we were really close. We didn't have a lot of buffer to spare. And so the windows that we would be selecting would be critical, as well as all the other variables that would be included would have to be really, make sure that we nailed them so that we didn't exceed as we evolved. And about that same time, or shortly thereafter, my wife and I also kind of came to the conclusion that we wanted to do a single-story home primarily versus a two-story. If you notice this image in the previous slide, there was a fair chunk of the project that was a two-story portion, but for various reasons, we decided to go to single-story. And single-story, as you might know, in this case, inherently makes the form factor worse because we're kind of sprawling out more on the ground and enclosing the same amount of square footage with more envelope than we would have had otherwise. So that was starting to eat into that buffer factor that we had. So we had to, again, really watch that closely. And so Enrico at EMU and I both sort of came to the conclusion that it made a whole lot more sense for the next phase of the energy modeling through Design PH to move to my court versus his court, so I could play with all these various variables myself and get really quick feedback. And that was super fun to be able to have that kind of quick feedback, and super fun when the software was working well. This was an older version. This was about 3 years ago, older version of Design PH, and it was pretty buggy. And although some of that might have been me, but I understand that other people experienced the same problems. But so it was also super fun and super frustrating, but ultimately it was really helpful to arrive at, my sense of what I wanted to do with the forms and the shapes and all of that relative to the passive house goal. And I could pick and manipulate things to get to where we wanted to be to still achieve the goals. One other thing that was sort of frustrating at the time was the shading tools in Design PH were not very sophisticated. So these flat roofs that you see here are solid, and I wanted to play with doing more open rafters or trellis elements to improve the performance, but the software did not permit that at the time, but that has since been remedied. One of the interesting thing to note is the form factor of my home is not super great. Most successful passive house projects that you see are generally kind of one pure gable form as opposed to 3 gable forms that are connected with flat roofs. And so the better the form factor is, the easier it is to achieve passive house. And oftentimes that maybe gets emphasized pretty heavily, and I think people are scared to try maybe some different forms. But ultimately we were able to make the forms a little bit more complicated and compound-like, and yet still, achieve passive house certification despite, not the ideal form factor. So the envelope, here's a cross-section of the building. This is all based on systems that EMU had done in-depth analysis to try to achieve systems that meet the passive house criteria for our climate zone and yet still be user-friendly. You can kind of see here that variation in the roofs. All the floor system is pretty much the same assembly. The walls are more or less the same assembly, but we've got 3 or 4 different roof conditions in the assembly. Here's a little closer view of a couple of the wall sections. And so basically the floor assembly is a 5-inch concrete slab that has radiant heating and cooling in it over a vapor barrier, over 8 inches of EPS. It's actually 2 layers of 4-inch with the joint staggered, and then foundation insulation is also EPS. Otherwise, we attempted to avoid foam insulation anywhere. We just opted for the foam underground because the other options, gravel and Gutex and rock wool, et cetera, were quite a bit more expensive than the EPS. Obviously better environmentally, but we weren't as worried about the vapor open versus vapor close aspects in those assemblies like we were for the walls and the roof. The walls are double walls with a service cavity. So basically you've got the siding on a rain screen, you've got a WRB sheathing, an outer 2x6 wall, a gap, an inner 2x4 wall, then the air and vapor control layer, and that's all filled with fiberglass, blown in dense pack fiberglass. And inboard of that is a service cavity that is 2x3s at the walls and 2x4s at the roof. And all of our utilities are running that service cavity, and then it's insulated with bats, and then the interior finishes. The roof predominantly is the image you see on the left there, the upper left, is primarily parallel core trusses that are treated somewhat in the same fashion as the walls, other than it is a vented attic. So there's a vent space there, the truss, the air and vapor control layer inboard of that, and then the 2x4 service cavity. And then we have a couple other roof sections where we have a conventional flat cord truss with an attic above. And then we also have some attics that are unvented. And we had to do a little bit of gymnastics with the local building department to prove that out. Enrico provided some very good modeling and reports to prove the case there. And then the windows are all triple pane, smart wind windows made by Advantage Architectural Woodwork out of Colby, Kansas. And we tuned the SHGC factor relative to the various orientations. The systems for the house, as most of you know, Passive House lowers your loads to the point where your HVAC systems can be much less robust than they are for a typical house. However, my wife and I both opted for radiant floor heating and cooling due to our love for that approach, and also the time frame we were making that decision. We happened to be traveling in Europe, and we were freezing our butts off everywhere I went, or everywhere we went, had the influence decision. So we did not need to do that. A typical mini split system would have worked just fine for the house. Another goal of the project was to be fossil fuel free, both for environmental reasons and at the site. So it would have cost a bit more to bring that in. So we ultimately went with the ground source heat pump, supplied by a couple of 250-foot deep geothermal wells. Of note, if we would have gone to the mini split system, it would have saved somewhere between $15,000 and $20,000. So it was a significant choice to make that decision. We're well aware that we didn't have to do that. That could make Passive House more affordable. You also might be interested to know we looked at air source heat pump versus ground source heat pump. And if you're looking purely at those costs alone, there'd be a significant savings to go to air source heat pump there as well. However, when you applied the federal and the local tax credits to the heat pump scenario, the differential ended up only being about $2,000. And we thought that was money well spent to deal with super low temperature conditions where the air source heat pumps aren't as proven yet. They keep getting better, but not quite as proven yet. So opted for that. ERV is on the right there. It's a Zender ERV Comfo Q450. And then you can see a lithium battery for our solar system on the left there. That just got installed actually last week, so that's a fresh photo. Here's a photo on the left of them doing the geothermal wells. Like I said, they're 250-foot deep. Just a 2 or 3 ton system, again, due to passive house, low loads. You know, if we were dealing with a typical house of this size, it'd probably be more like 400-500 foot deep well, something along those lines. Then we have a PV system, 5.8 kW system you can see on the right. This was sized by EMU Systems to meet net zero source energy loads based on the PHI primary energy renewable method. And then, like I said, we just got a battery here lately, so we can shave our nighttime peaks and access our nighttime potential and shave daytime peaks, etc. Getting into the details of the house, I'm going to just touch on a few. There's obviously a ton to go through, but we'll try to just touch on a few. One of the interesting things that EMU always talks about, Enrico in particular talks about thermal breaks, and some are elephants and some are mice. And we want to try to remove the elephants, and the mice maybe not worry quite as much about. But the elephants generally have to do with concrete and they have to do with steel because they're much higher conductors, of course, than wood. And so one of those elephants in our case is a foundation. And so we have, if you might recall from the floor plan, we had that shop and garage area that's connected to the house. And the house is where the primary thermal envelope is, and the garage and shop are secondary envelopes. And so we needed to break that foundation. It's a very easy detail as long as you just do it at the right time. Basically there's a piece of foam stuck in the form at that point, and the steel rebar runs through. So technically the rebar is still bridging, but it's a smaller bridge. Quick one, here's a radon vent. Typically, and we do have radon issues here in our locale. Typically a radon vent, as you all know, will come through the floor of the house, go through the interior space, and then back out through the roof. And so you've got two penetrations of your thermal envelope, one at the floor and one at the roof, as well as you're potentially increasing your potential to bring the radon in, I suppose, in that scenario too. So we just did a little workaround where we kept it entirely outside of the air and vapor control layer within the walls. So again, not a super hard deal, just needed to be thought about time of foundation and get that worked into the formwork. And obviously you got a little bit of a sequence, you bring in a plumber in a little bit earlier or doing that yourself. And then here are some details about sealing around the blockouts. By the way, I've heard someone say primarily what this is all about is taping and trying and caulking and carrying. And I think that is really true with these details here. It isn't a massive effort. It's more just about taking the time and thinking about it and doing it. And so this detail is the column blockouts in the slab. And so you can see the floor slab is all ready to pour there on that image on the right. The air or the vapor barriers in, the rebars in, the tubing for the radiant floor. But we had these blockouts where we had columns inside. They're typical. But what is not typical is we wrapped each of those little boxes like a Christmas present from the underside. And then once that was done and they were inserted, then we unfolded sort of the sides and taped that back down to that vapor barrier so that there was continuity at every blockout in that system. And then the image on the left, you can see after the slab is poured and doing a little damage repair taping there, where there's breakdowns and so forth in that membrane. Moving into the framing stage, this won't be unique to most of you, but we had to work our air and vapor control layer into the framing. So you see in the upper right there, the Siga Myrex, in between plates on top of that beam, so that the sealing on the underside of the left framing, when we put the control layer on that, can be continuous through those plates and then reach the flat ceiling on the right-hand side. You might also notice there's some openings in those plates in the anticipation of the ventilation. Easier to cut those out now than later. Here's the threshold detail. So this was probably the trickiest detail in the house. Because we're slab on grade, the thresholds were more complicated. Obviously if we were on a crawl space, this detail would be a little bit more conventional, but with the slab on grade, we needed to stop the slab short. As you all know, the typical way doing these openings is just have the slab run through the opening, out flush with the foundation, and then you set the door on top of that. The doors that go on top of these are actually pretty heavy, robust doors. They're 10 foot wide and 9 foot tall lift and slide doors, so pretty heavy. So this had to be pretty robust to carry that, and yet still, not be a thermal bridge. So the detail we ended up with is kind of this railroad track detail, where we've got these 2x4s spanning from the top of the foundation over to a 2x4 that's resting on the insulation underneath the slab. The mistake we made that I wouldn't make a second time is that when we poured the foundation, the blockouts in the openings, typically when you do those, you're not too worried about quality control at the top of that blockout, because you're just going to pour the slab through the top, over the top of it anyway. And we didn't think any differently at the time, unfortunately. But later, when I started to put these railroad track in, I quickly realized that that top of that foundation was completely inconsistent. And so this required all that dadoing that you see on the left there of that plate, and then shimming in some cases of that foundation and taping it. So there's definitely an easier way to do this. Detail primarily would be just to get that foundation flat, but there may be some other solutions as well. But this was a tricky one. We're actually now looking at a window sill versus a door threshold, but the idea is the same. So on top of those blocks that you saw in the previous image, we created these little taper blocks to create slope of the sill, and then the jamb you see on the right there got packed out so that the framing and the insulation could wrap around the face of the SmartWind windows. These windows allow you to cover them up, other than the sill condition and insulate. As you all know, the frames are the weakest part, so this sort of helps to mitigate that. We're back to the threshold here, but again, the same idea. Then in between each of those railroad tracks, we insulated with rock wool. This was still in the construction phase, and so that was subject to getting wet. Rock wool obviously is hygrothermic, so it's the great solution for using in this condition. It's still subject to that. Then that sloped condition gets covered up with OSB and the and then after taping, we inserted the Gutmann sill pans, a beautiful product from Gutmann in Germany. Took a lot of effort to figure out how to make those all work. I'm sure they've got that system down to a science, but it was new to me. So it took a little bit of practicing with that. Then I realized I don't have a lot of photos of the outside as we finished up the windows, and I was looking for them back when I first started putting this presentation together, and realized I think the reason I don't have a lot of photos is because of the conditions. This is Thanksgiving morning, 2019. That morning I was out taping these windows. I'll always remember that on Thanksgiving morning, but definitely not the time you want to be out taping with this kind of thing going on. On the inside here, you can see now, I have to skip the outside taping, but because of those photos, but on the inside, you can see back to the railroad tracks here, connecting the inner walls to the outer walls. Then the windows, before they were put in the holes, were pre-taped so that we could get access to the windows. And then after they were in and taped, we then put the inside vapor control layer up over the 2x4 framing, sealed that all up and blew the insulation in. And then I should mention, we also put the service cavity framing to help hold the Myrex. What you're seeing here, interestingly, is the 2x3s around the windows had to be left out until we completed the insulation in order to be able to stick a hose in and blow into that cavity where the railroad tracks are. What you're seeing here is this blue tape is marking a cavity that did not get filled to the way it should. So we had to leave that 2x3 out, mark it with the blue tape, get the insulator to come back and get that topped off, and then add the 2x3 later. Not too much of that happened, but some. And then now you see it after the insulation's put in, the 2x3s are completed out. Another elephant here is, and it looks like I should wrap up in about 5 minutes. I'm gonna move this along, but another elephant here is the steel detail. So we have several places where steel beams meet outside walls, and the typical condition is for the steel run out to the outside face of the wall framing. What we did is we held all of the steel back about 1.5 to 2 inches to be able to sneak in a rock wool bat behind the ends. And then a tricky little detail here that Enrico pointed out to me just at the right time as we were framing, we were putting those plates on top of those steel beams. And he mentioned this great tip to stop the first short of the wall. You can see that where that arrow is pointing, there's a gap there, and that allowed us to tape that air barrier, air and vapor control layer, straight to the steel as opposed to straight to the wood. The completeness of that condition, or the tightness of that condition, is much more enhanced when you're connecting steel to control layer versus the wood. So interesting little detail. I'm going to skip that for now. So ventilation, something I have always done for all my projects, commercial and residential, over the years, is always try to work closely with the mechanical designs to coordinate where all of the ductwork and so forth runs through buildings to make sure we've got a route for that. But I had to take that to another level with my own house, building this myself and not really having a true mechanical engineer involved. I did this layout of both the structural framing and the service cavity framing and the lighting and the ventilation. And so that I would normally probably thought of that as kind of drudgery work, but it kind of became fun. And I think something Passive House has done for me is given me a greater appreciation for some of these systems, particularly HVAC systems. So an interesting side effect there. Here's a photo of that in reality. So you can see at the top, that's the ventilation running through the service cavity where it runs perpendicularly. The service cavity framing has to be uninterrupted. Where it runs parallel, it's pretty easy. Here's a case where on the right hand, you can see it running parallel. On the left, you see it perpendicular. An interesting note is the Zender boxes for ventilation don't quite fit in a typical 2x4 depth. Need an extra 3/4 inches. So you can see the 3/4 furring on the bottom to make that happen. An interesting side note, maybe that can be improved upon someday. Furring's not a huge deal, but a little added step there. Same thing applies here. You can see this is a wall condition, and that it's hard to tell in the slide, but there is behind that box, and you can sort of see it more to the right of the box, is green tape. We had to create a little pocket recessed into that truss cavity, in this case, that was all sealed up in order to fit that Zender box in that 3.5-inch framing without having to fur out the entire wall. Here's another view inside the primary space. You can see more completed now, their control layer throughout. You can see the collar tie brackets on the left and the right there. They were mounted to solid blocking out inside of the control layer, so we didn't penetrate the control layer with that steel. You can see those vent holes from the previous slide now, in play, where they're actually got the vent piping through them. See a few more cases where there's blue tape marking cavities that weren't quite full that had to be topped off. Here's the outside rain screen. Had to be double layer at the bark siding, which is nailed horizontally, and single layer just vertical at the white cement fiber. Here's the bark siding. Interesting learning point here, the tar paper that's between the layers of bark. I initially didn't think that was needed since the house water control layer is back there, the Seagum iBest. Didn't seem like it was needed, but later learned that it was there, needed to be there to protect the top of the shingles, the bark shingles. So basically the joints between each shingle would allow water to get in and potentially get on top of the course below that. So that tar paper is there to protect that, the way they've been installing it for many, many years. There's our blower door test. We achieved a 0.44 ACH 50. We did 3 blower door tests, 2 preliminary and 1 final. Could talk more about that if time permits. Living in a passive house. We've been in here since October now. Went through the winter, went through some very cold spells. We had a spell in February that it was -10 for days. We wouldn't even know that inside the house if we didn't go outside. It was so well controlled. These big windows and doors, you could walk beside them in your underwear and not feel any drafts. So fantastic. We've had a lot of wildfires in our neck of the woods the past few years, and so having that Indoor ventilation system run continuously definitely gives you a lot of peace of mind in that regard. Our ventilation system has worked quite well. We had to work out a couple of bugs initially, but those have all been worked out. Things have been going well. Have changed my filters twice now. Both times found a lot of ash in them from those fires. So good to know that's all being caught. Sound is another pretty interesting issue. We live next to a state highway. It's not a major volume state highway, but there is some significant noise there. And again, if our windows and doors are closed, we have no perception of that whatsoever. I'll conclude with a photo here of what's yet to come. So we're currently trying to get some landscape in between rain. We've been getting a massive amount of rain and snow the last few weeks, and we're actually a couple inches above average rainfall, where the rest of the state and many other parts of the country are in a drought period. So we're happy about that, but it's definitely delaying the landscape. But this is sort of what's yet to come. So with that, I'll open it up to questions. Do I need to stop sharing my screen, Ken?
I don't think so. It's
Okay.
such a beautiful image.
Yeah.
So fantastic presentation. And if anyone has questions, you want to type them into the chat or put on your video and make yourself known, feel free. I know I definitely have some questions, and I think Andrew might as well. One thing that definitely jumps out any passive house person is the form factor, right? It's like, that's not a box. There's quite a lot, not just of articulation, but really just a lot of surface area there, right? I'm just curious. I mean, one can see this in other examples where you can make it work. But I was wondering if you could recall like any particular levers or things that you saw had outsized effects. I know you've got really good windows, right?
Yeah.
Which I think helps a lot.
Yeah, the one interesting thing back, you remember the site plan image I showed, and that we ended up going orientation 10 degrees off of center. So there's a little bit of an interesting story there that, you know, most folks kind of feel that if you're within 20 degrees of true south, you're probably okay. And I ideally would have liked to have oriented the house at 20 degrees as opposed to 10 degrees. 20 degrees would have paralleled that north property line, would have opened up the front of the house a little bit more to the street and closed down the garage view of the house, et cetera. So those were architectural reasons I would have rather had it skewed a little more. But that 10 degrees of rotation was resulting, at least in the design pH stage, of about 0.7 or 8, if I remember right, in the scale of 15.75 allowed total heating load. So It was a fairly significant piece of the puzzle. So I opted to go to 10 degrees versus 20 to give us a little more buffer in the early stages when, you know, before we come to certification. So I was a little surprised how much 10 degrees impacted, you know, that criteria. So that was one of the bigger pieces. The other bigger ones are the shading, you know, all those south facing windows. So, you know, those roofs that you see there on the right, those flat roofs, you know, they serve other purposes. They're walkways, they're a screened in porch, they're outdoor living spaces, but they also serve as great shading devices for those windows. We don't have any blinds on those windows because of that, et cetera. But more optimally, performance-wise, if we could have poked a few holes in those, we could have gotten, you know, big gains in the winter that wouldn't have hurt us too bad in the summer. That ultimately led us to putting those clear stories above the flat roofs to kind of regain some of that. But I think that more sophisticated design pH package now would have helped us better optimize those. So those are a couple of the bigger ones that stand out.
Yeah, great. Andrew, do you want to throw out a question?
Yeah, first I wanted to do a super quick announcement that tomorrow we're going to have the Passive House Rocky Mountains members meeting, and that's at noontime. And you'll be able to, here, I'll share it on, I can share it on our chat, but also you can find it on the North American Passive House Network's calendar. And the reason why I'm bringing it up is because right now we're getting a lot of emails from people from all over the states, from kind of this huge region, asking for design professionals. And North American Passive House Network now has this great members directory that we're basically referring everybody to. So if you're a Passive House practitioner, I think it's a kind of a nice opportunity to get in front of ahead of people who are looking for leads and looking for information on Passive House in our region. So just wanted to push the plug there. And then if you remember, of course, you get to join our really awesome group. And Greg's been part of it. Ken's been part of it. I think we've had some really fun, delightful, like inside information conversations. Market's hard. So just wanted to throw that out. And my quick question, Greg, is the roof. Holy crap. Code is very difficult when it comes to unventilated roofs. I know that all our roofs are unventilated, but it's very difficult to get code officials to understand what we're really doing. A lot of them say, we don't care what your calculations are, your WUFI models, just do it as the code says. So how did you guys sneak that one through?
Yeah, we could probably do a whole session just on that, actually.
Maybe we can talk about it tomorrow if you're going to be around.
Yeah.
What's that?
Maybe we could talk about it tomorrow if you're going to be.
Yeah, maybe.
Around.
So the shorter story is Enrico did about a 20-page report that proved out the logic of things using more modern and more sophisticated software tools than using just the dew point method that the code is based on. The longer piece of that was got into, and boy, I won't have enough time to really give this all its due, but the longer piece of that got to be that we had to install the SIGA Myrex interior air and vapor control layer 100% to the manufacturer's criteria. That was a condition that the building department put on. And due to the fact that we had framing at 2 foot on center versus a more European module of framing, the SIGA Myrex did not have anything in their corporate criteria that allowed for that setting of the framing. Okay. And so we had to do a bunch of, there's recommendations off the record that we could do, and they felt really good about it, but not on the record. And so we had to do a bit more framing there to accommodate that. We also taped all of the staples in the SIGA Myrex in those locations, which isn't necessarily a requirement of SIGA, but we did do that just as a added measure. But the story could get much longer on all of the spacing aspects and how you roll the Myrex out relative perpendicular to framing versus parallel to framing, and et cetera, et cetera. But ultimately the building department accepted it as long as it was 100%. They did a special inspection on just those roofs in addition to their normal inspections to verify that that was all in good order. So that's the short story.
Wow.
Well, let's hear more tomorrow. We'll get into some of the details.
Yeah, I'll send you the 20-page report.
We'll hand you the second half of the meeting.
Yeah.
Hey, we have a heat pump question. Yeah. Go ahead, Ken.
Well, I was just going to bring that up. The heat pump question from William Boston that recently moved here from the UK. Welcome. So many great things happening in the UK with Passive House. Happy to have you here to join the fun here. That heat pumps and Passive Houses is worked with, often the case, especially underfloor heating. The heat loads were so small that the heat pump would cycle, reducing the efficiency. Have you noticed any issues with cycling on the heat pump?
No, and I'm probably not the best person to speak to that. My mechanical folks could probably better speak to it, but the system, the heat pump that we did select is a 2-ton heat pump. So it's a smaller heat pump designed for the smaller loads. And that was sort of a story in itself. It took us a while to find a heat pump that was that small and produced the data that we needed to prove things out with PHI. We found one heat pump that was a better fit potentially, but didn't have the data to back it up. So we actually ended up jumping up a ton, went from a 2-ton to a 3-ton heat pump just to get the data that we needed for no additional expense, but it was a bigger one. But I don't believe there's any unnecessary cycling going on, but I could be corrected on that. I'd have to check with my HVAC guys to see how I would determine that even. So
You don't hear it turning on and off like
no,
it cycles.
no.
Yeah, that's good. Good. Yeah, getting it small enough is the key. So I had a question. Well, I'd like to slide in. Well, I'll start with the one, but it's not as serious a question. Maybe is that mechanical room is amazing. It's not only spacious but beautifully laid out. You made a really conscious choice there to give your mechanical. Usually, everybody, especially coming from a place like where I am in New York City, where there's no room for mechanicals and it's all on top of each other.
Yeah, thanks for noticing that. I mean, we really did put a lot of effort into that, and I will credit, Forge Mechanical was my mechanical contractor, and they were really fully on board with that whole approach. Some of the other subcontractors were not quite as on board, and we had to do a lot of defending of territory to make things get finished out the way they were. And in all honesty, there's a few areas that don't show up in that photo that didn't get treated quite as nicely as the rest. But we did work very hard to try to make that, both visually pleasing and also, I think like anything, if you keep a job site clean, if you do these things, the level of care demonstrated in the surface elements, hopefully shows the level of care that you used in the things that don't show too. So, yeah.
I'm just curious, not to belabor it, but in other projects or whatnot, I mean, you're trying to reduce the size of the house, and yet you've got this mechanical room that could be another bedroom, essentially. And is that something like, were you thinking about it differently on this project than before? Or
I would say primarily I was in the sense that we don't have a basement in this house. We have a high water table, so we weren't able to do a basement. And so normally having a nice size mechanical room, and most of my projects have basements. And so doing a nice size mechanical room down there is usually a no-brainer. But in the fact that we don't have that basement, and then we had to carve out more of our prime real estate to do that. Yeah, it was, like you said, about a bedroom size. So it was a little bit more of a conscious effort to, make that all work, if that makes sense.
Yeah. Yeah. If I could just throw in there, Andrew, I was curious on the net, on zeroing out. Have you gone for like Passive House Plus or Premium in the?
I would like to have, but and I know enough about this to be dangerous, but the way I understand it is that Passive House Plus factors in, makes it really tough for single family to achieve the criteria. Not deliberately to achieve it for that, but it's trying to balance out the fact that much denser high-rise projects, for example, have much less roof area. And so there's criteria to try to balance that would actually cause a project like mine to become net negative, like fourfold, to compensate for that area. So it's a flaw, in all honesty, in how Passive House Plus works for a single family. To achieve it would have been ridiculous for me to do. Like I said, it had been net negative like 3 or 4-fold to achieve it, because I'm not a high rise with that kind of proportionality, if that makes sense.
Also, Greg, aren't you pretty close to the threshold for the heating demand?
We're at 13 point something, if I remember right, Andrew. So there's a little bit of spare there, but not.
So if you're a little bit lower, then it's a kind of a sliding scale. So you can definitely, like our projects meet plus pretty easily, but usually we tend to do a lot more passive solar than you do in this climate. So it's maybe not as hard. It's not as penalizing, I think, for us once you get to like a maybe half of the certification for insulation, for instance, or for your heat demand. But
yeah, it's something I'll need to learn more about. All I know is I talked it through with Enrico, who knows this stuff inside and out, and asked him, to try to achieve that. And that was sort of the the information he gave back to me was we'd have to massively increase the PV to achieve that. And,
Yeah,
and
that's
quite
what we
honestly, I didn't need another badge, for it. Just I wanted to do right by my own loads and supplying my demand. The passive house certification itself was adequate for me to prove that we've done our job. So
Yeah, well
Next
done.
time, Greg. Next time. There's
Yeah.
always something more, right? They always dangle more carrots up there.
Yeah, and I think the next time is to focus more on the carbon aspects, but yeah, always something more. Yeah.
Great.
People are coming in right at the last minute. So
Yeah, I think we have a time zone issue in the announcement or something that we should apologize, I guess, for those that are coming in who thinks this is just about to start when we're just ending. We will have this, the consolation is that we will have this recording made available in the next week. It will be on YouTube and we'll be putting it out. So we definitely look forward to doing that. And sorry to those of you who think is about to start. We just had a great presentation and a great discussion. And I want to thank Greg a lot for it today. And I guess we look forward to continuing the conversation tomorrow at the Passive House Rocky Mountains meeting. So if you're in the Rocky Mountains, want to be a member, come to the meeting. It will be a great discussion. And thank Andrew and everybody for coming.
yeah, thank you, Greg.
Thank you all.
Fantastic details, Greg. Really exciting to see.
Yeah, amazing project.
Thank you.
All right. Have a good day, everybody.